Alright, we want to see if these two norms are equivalent. So, just let's let x1 denote the space x endowed with the 1 norm, and x2 be the space x endowed with the 2 norm. This will be useful for just telling them apart, because they're not, even though it's on the same space, they're not the same space. Or, like, the structures are different. So anyways, let's start. The identity map, not nap, which would be nice right now, but map I from, this is going to go from x2 to x1. So it's the identity map, so it just sends x to x, but in terms of spaces, you've got different norms on the spaces. So anyways, I'll stop. There's some word with a B that describes what I'm doing right now. So this is a bijective bounded linear map. Well, okay, it's a bijective linear map which is bounded by assumption. And that's because if you take the 1 norm is less than or equal to the 2 norm, so let's just put this in parentheses. I of x is equal to, so I of x, this is the 1 norm of this, is equal to just the 1 norm, which is less than or equal to the 2 norm. So thus I is continuous. Since x1 and x2 are Banach, and I is surjective, and it's a surjective element of linear mappings from x2 to x1, then by the open mapping theorem, I is an open map. I'll just say I is open. So I inverse is continuous, not its, but is continuous. So there, and so, okay, so I is open. So I inverse is continuous. And since I is a linear bijection, I inverse is as well. I'm saying a lot more words than necessary here, but we might as well. So I is a linear bijection, so I inverse is as well. So I is bounded, i.e. the norm of I inverse is equal to some m, which is finite for some, so this is for some m. So for all x in x, norm of x1 is less than or equal to norm of x2 by assumption. God, my handwriting is awful. And x2 is equal to I inverse x2. Now, remember here, since this is I inverse of x, x here is being treated as an element of x1. So when we do less than or equals to and break this up into its two norms, the norm that pops out here is the 1 norm, because here we're treating x as an element of x1. And what is this? This is precisely mx1. So the 1 norm is less than or equal to the 2 norm, which is less than or equal to a constant times the 1 norm. And what does this mean by definition? This means that the 1 norm is equivalent to the 2 norm. And that finishes our proof.